Hi everyone, I'm Hua from the Institute of Computing Technology, Chinese Academy of Sciences. Our paper is titled with ReconBoost. Boosting can achieve modality reconcilement. It's my pleasure to share our recent research through this video. Jointly worked with Qian Qianxu, Shi Longbao, Zhi Yongyang, and Qing Minhuang. Now, most real-world data usually follows a multi-modal nature in various fields such as data mining, computer vision, medical diagnosis, information retrieval. Because of this, deep learning community has recently focused more on multi-modal learning. The prevailing paradigm in multi-modal learning typically employ a joint learning strategy. A wealth of studies primarily focus on integrating modality-specific features into a shared representation for various downstream tasks. Despite its success, recent work points out that multi-modal joint learning encounters modality competition, where some modality overpowers the learning process. To reveal the reasons behind this, we expand the gradient update rule of the case modality learner and find that if the gradient of the case modality learner approximates the gradient of the whole model, then the case modality has a consistent gradient with the shared score. We call it the dominant modality. Following this update rule, the dominant modality converges more quickly and would eventually overpower the whole learning process. On the opposite, weak modality has an inconsistent gradient with the shared score and will be stuck at bad local minima. Following this way, joint learning tends to neglect the gradient from weak modality. Here we give an example. The phenomenon of modality competition is observed in the contact fusion method when applied to audiovisual dataset. From this figure, we can know that the learning process is preliminarily influenced by the audio modality, which is exactly the dominant modality mentioned above. It will lead to insufficient learning of the image modality. Various studies have been made to mitigate the modality competition issue. The primary concern is how to balance optimization progress across multimodal learners. Despite the recent efforts to design various rebalance strategies to avoid modality competition, only limited improvements can be achieved, given the nature of joint optimization. Motivated by the limitation, we ask, can we achieve modality reconciliation via other learning paradigms? In search of an answer, we explore a modality-alternating learning strategy, namely ReconBoost. We first introduce the naive vision of the modality-alternating learning. In step 1, we carry on the alternating training procedure. Each time, we pick a specific modality learner to update and keep the others fixed. Then the gradient rule is shown as here, where theta k is the parameters of the case modality learner. After the alternating learning, we merge the multi-modal score to obtain the final score. Following this way, when model updates are alternated, the gradients across different modalities are naturally distinguished from each other, elevating the modality competition issue. This approach ensures the exploitation of uni-modal features, but neglects the investigation of cross-modal interactions, limiting overall performance. So, we are motivated to design a more effective modality-supervised signal to explore the interactions between modalities in alternating paradigm. At each fixed time s in the update in step 1, we explore reconcilement regularization term by introducing the reconcilement regularization term ds. Here, ds could be a diversity measure between the current modality learner and other learners. Here, in each round, we try to maintain the trade-off between the agreement term, which aligns the overall predictor with ground truth, and the reconcilement regularization term, which leverages the complementary information between modalities. Then, step 2 is the same as that in the naive version. However, at first glance, the overall optimization property of ReconBoost is unclear. To further explore its theoretical foundation, we investigate the connection with the well-known gradient boosting algorithm. So, in this theory, let the reconcilement regularization be a KL divergence function. We have the following optimization property similar to the gradient boosting algorithm. Here, optimizing the dynamic loss function L tilde. In ReconBoost, consistently optimize the original loss L with a progressively changing pseudo label. The pseudo label is the gradient descent step for the current type. So we say that the optimization of our method resembles gradient boosting algorithm. To sum up, the pipeline of our ReconBoost is shown here. Our proposed method can release an alternating version of the well-known gradient boosting method, pursuing a reconciliation between the exploitation of uni-modal features and the exploration of cross-modal diversity. Empirically, we provide the evaluation across a wide range of multi-modal data sets to show the superior performance of ReconBoost. Additionally, we evaluate the performance of modality-specific encoder. It further demonstrates that our method can address modality computation issue effectively and achieves reconciliation between modalities. In conclusion, to address the notorious modality computation issue, we propose a novel multi-modal alternating learning paradigm to achieve modality reconcilement. Theoretically, we show that by choosing a KL divergence-based reconcilement term, our proposed method can release an alternating version of the well-known gradient boosting algorithm. Experimentally, comprehensive experiments justify the effectiveness of our proposed framework on various multimodal scenarios. That's all. Thank you for your listening. We look forward to further discussions and feedback on our work. Thank you.